like fun for adults too. I'm just saying. Yeah. STEM is not just for students. Our next speaker is Matt Dunn from SpaceX, and a lot of our speakers today have referenced the innovative culture that exists here in California, and I think SpaceX clearly is an example of how that innovative culture entered into the space industry and is really doing a lot for the industry and forcing everyone to take a look at what we're doing and making sure we're doing great. And they've just had some wonderful successes. If you've had a chance to visit the plant down there, you walk in and it's just energizing to go down there and see the great things that are going on. And we're going to get a chance to go visit tomorrow, so I'm very excited to go back. Matt is the Director of Government Affairs at SpaceX, and so he works in that intersection between technology and policy and coordinating the federal, legislative, and executive agency affairs for the company in D.C., focusing on the defense, the national security, space launch, export, really just everything, coalitions, and then policies in general that help the competitive U.S. industry in general, and along with that, overseeing political affairs. He has extensive legislative experience before he joined SpaceX in January of 2011, so I'd like to invite Matt up.
Well, thanks, Sandy, and thanks, AIAA, and thanks to all of you for hanging out with us for a couple of hours and listening to us talk about ourselves. We appreciate it. We're going to start, because it's a theme, with the video, so if you want to play that.
Dragon is in orbit. Instrumentation looks like we got us the Dragon by the tail.
So SpaceX was founded in 2002 by Elon Musk, who you may be familiar with from PayPal. He's also the CEO and CTO of Tesla Motors. We have over 3,500 employees at this point. Most of those are centralized in Hawthorne, California, incidentally at a former Northrop 747 fuselage assembly factory on Jack Northrop Boulevard. We are manufacturing the world's most advanced spacecraft and launch vehicle systems in the Dragon and Falcon9 family, using American innovation and technical know-how with a supply chain throughout the United States. So you see a little bit of our presence across the country, concentration in California at Vandenberg Air Force Base, which is our West Coast launch facility, and in Hawthorne, California, which is our design and manufacturing facility. We have somewhere near 3,000 suppliers around the country. SpaceX is heavily vertically integrated as a manufacturer, so we do most of the fabrication of the vehicle systems ourselves, but we have a supply chain at lower tiers that supply us. 1,200 of those are in California with hundreds of millions of dollars in annual spend. You can see some of the blue coloration on the chart there, which reflects where most of those suppliers are concentrated. This is a photograph of what we call tank land at the SpaceX Hawthorne factory. You can see the first stage booster cores being fabricated and finalized as they are about to move out of the building. All the way on the end there, you see the 9-engine configuration, which is on the back of the first stage of a Falcon 9. That octaweb truss structure with those engines has been integrated. Those next vehicles on the line will roll over and they'll be integrated with the engines as well. At this facility, we've got more than 1 million square feet of manufacturing space and design and engineering space. We've acquired a number of buildings in the surrounding area as we expand to meet new rate production to support the commercial needs of our manifest. We also maintain, as I mentioned, a launch facility on the west coast at Vandenberg Air Force Base at Space Launch Complex 4 East. We're also developing a landing pad adjacent to Slick 4 East. We have a number of flights coming up for customers that will go into this polar orbit, including Iridium. We've got an upcoming NASA scientific mission that will fly this year as well. Incidentally, we first flew the Falcon 9 version 1.1 with a commercial customer, Cassiope, for the MDA Corporation of Canada, and that was the first commercial launch from Vandenberg in a very long time. SpaceX, as I mentioned, manufactures the Falcon 9 launch vehicle. You see it there in two configurations. On the far end, you've got a 5-meter fairing configuration. This is where we emplace satellites, and that aerodynamic shroud encapsulates the payload to protect it on ascent. Next to it is Falcon 9 with the Dragon spacecraft on top. That's the configuration we fly for NASA as we deliver cargo to and from the International Space Station. Later this year, we will debut the Falcon Heavy in its inaugural flight. This will be quite a launch vehicle. I think double the capacity of any launch vehicle currently flying, just shy of the old Saturn V launch vehicles. And between these two launch vehicle systems, we will be able to execute 100% of any customer requirements, civil, national security, or commercial. Meanwhile, we're currently flying Dragon, Cargo Dragon, to and from the space station. We've done a number of flights, 6 so far. 5 of those have been operational flights for NASA, delivering about 5,000 pounds of cargo to and from. Dragon is the only spacecraft available visiting the ISS today that has significant down mass capability, which means we can bring the important scientific research and experiments that are conducted on the ISS back to Earth. This was a function previously provided by the Space Shuttle, but once we decommissioned the Space Shuttle, the international partners, including the United States, had no means really of bringing significant cargo back. So Dragon is that capability today. The Crew Dragon is online and in development. We recently were awarded, along with Boeing, as the other awardee, to develop new human spaceflight systems for U.S. And international astronauts to the International Space Station and from. So we anticipate the test flights for Crew Dragon to occur in the 2016 period, with operational flights beginning in 2017. So we will no longer have to buy rides to space from our friends in Russia. Falcon 9 has had a pretty stellar track record so far. We've now executed a total of 16 flights, all of which have been successful missions for a wide array of customers, including blue-chip commercial customers, NASA, including the cargo flights, as well as the Air Force, where we just launched a payload called Discover to an orbit 1 million miles from Earth. Recently, as Darrell mentioned, we just deployed 2 of Boeing's innovative new electric propulsion satellites to their orbits. You actually saw one of them being dispensed in the video. SpaceX serves 3 primary markets. We have a diverse mix. You see what that looks like in the pie chart there. Roughly 60% of our business is non-U.S. government, so we're looking at allied international governments and foreign customers and domestic commercial customers. We've got some U.S. government business as well that's significant, but in terms of our launch manifest, the overwhelming majority are for non-U.S. government customers. Civil space is cargo resupply to and from the International Space Station, astronaut transportation, which we'll be undertaking in the coming years, as well as scientific missions for NOAA and NASA for satellites to expand our knowledge. Again, the commercial market is a very significant market for SpaceX. We, as a country, had surrendered our competitive edge in launching commercial satellites to space. In 1981, for example, and I'll show this on the next chart, if you wanted to get something into orbit, you did that from the United States. In 2010, U.S. market share in commercial global satellite market, launch market was 0%. This year, SpaceX has picked up about a third of that, and next year we will have some 56% of that market. And there we are pulling that business away from the French and Arianespace and the Russians in their commercial business called International Launch Services. So it's a good news story for the United States. And on the defense side, it's no secret we've been long itching to get into the national security space launch business. That opportunity appears to have now arrived. We anticipate competing for these missions this year. This was the chart I was referring to about the commercial launch marketplace and how U.S. position had essentially collapsed due to really non-competitive pricing conditions. SpaceX brought Falcon 9 into the competitive mix, began fielding the vehicle starting around 2011, 2012, and you've seen sort of this spike in our recapture of this marketplace, which is a very good thing. Meanwhile, we continue to push the envelope on new technologies, including reusability, which is a very important goal for SpaceX. We have had a number of successful demonstrations of this technology, vertical landing and vertical takeoff, vertical landing, using initially our Grasshopper test article, which we flew at low altitudes at our McGregor test facility in Texas, then our Falcon 9, our development vehicle. We've done a couple of soft landings on operational flights where we will turn the vehicle around once it separates from the second stage and the payload is on its way to its orbit. We'll turn the vehicle around, fly it back, boost it back, and slow its descent using the engines on the first stage to a near zero velocity. A couple of attempts ago, we came very close to landing the vehicle on our autonomous spaceport drone ship named Just Read the Instructions. I won't explain that reference, but I encourage you to Google it. We had very good accuracy in crashing into the barge. We posted that video on YouTube, and it was an awesome day for SpaceX. I can tell you we were super thrilled about it. We'll try that attempt again on an upcoming CRS mission we'll do for NASA in a few weeks. So reusability is really a game-changing technology. Imagine if you had to, at every leg on a flight, you threw away an airplane and had to buy another one. Air travel would be unaffordable. If we can significantly reuse the launch vehicle, fully and completely reuse the first stage of the launch vehicle, we will achieve orders of magnitude savings and fundamentally reset the economics of space launch. So thanks for your time, and I'll look forward to any questions.